In this example, we're going to be finding the matrix of a transformation, linear transformation, relative to a non-standard basis. So for this example, we're going to be working in R2. We'll let t be a transformation that takes us from R2 into R2, where t of xy is going to be 5x plus 4y and 4x plus 5y. The non-standard basis that we're using is going to be the non-standard basis comprised of 12, negative 13, and 13, negative 12. So we're going to be determining a prime. Now, as we saw with our previous example, a prime is going to be equal to p inverse times a times p, where a is going to be the standard basis, or the standard matrix of t relative to the standard basis. We'll interpret this as first component, second component, coefficients of x, coefficients of y. So to create 5x plus 4y in the first component, that'll be 5 and 4. And to create 4x plus 5y for the second component, that would be a 4 and a 5. To create our transition matrix P, if we refer to these two vectors as v1 and v2, each of these will show up as a column within P. So v1 for the first column, v2 for the second column. So for v1, that'll be 12, negative 13. And for the second column, that'll be 13, negative 12. Then to create a prime, this is where we're going to let our calculators take over. So a prime is going to be p inverse times a times p. We'll load that into the calculator and see what we wind up with. So into the calculator, let's put these two matrices that we just created. So from the matrix menu, I'm going to edit matrix A, and A in the calculator is going to be the same as A on my paper. So it'll be 5, 4, 4, 5 for the components. We'll quit out of this menu, then we'll re-enter the matrix menu, and this time edit matrix B. B in my calculator is going to be P on my paper. Matrix P. Sounds kind of awkward. That's going to be 12, 13 for the first row, negative 13, negative 12 for the second row. Then we'll do a quick double check. Make sure that matrix A looks good, 5, 4, 4, 5. Make sure matrix B looks good, 12, 13, negative 12, and then we multiply. So in the calculator, we are going to ask for B inverse multiplied by A multiplied by B. My goodness. It's as if nothing has changed, and yet everything has changed. This will be 5, negative 4, and 5. So again, the significance of this matrix is it says starting with a matrix X relative to basis B prime. If we multiply by matrix A prime, then what this matrix does is it's going to transition X back to the standard basis, find the image of this standard basis vector through the transformation T, and then it's going to convert it back into a non-standard basis. So we transition back to standard basis vector, found the image of it from A, and then transitioned back into non-standard basis. So those three things wind up doing one thing. We can keep this in our non-standard basis, and all is well.